Hi, Teacher Jerry here. Today, the topic that we're going to talk about is on QA. Right, QA has two aspects. Right, one is the practical aspects. The other one is the theory. So, one of the most challenging is that you need to memorize the table, right, in order to answer your theory questions. But similarly, memory should always be the least worry. First important thing, if I give you the QA table, are you able to interpret them? And then after that, you need to practice. Okay, it's really more of practicing. So you can also catch the video on how I solve one of the questions. Right. The big picture is this. All right. Look at these three approach to a QA questions. Right. Act, test, and then you work backwards. That means you start with an unknown. And every unknown will have one positive or one negative ions. So we need to add chemical to it to check what is the positive, what is the negative. So this one will depends on the QA table. Then, of course, after we identify the possible cation, anion, we need to put it backwards because that will help us understand what is X made up of. Of course, not every unknown is one positive, one negative. There can be two positive or two negative, but at least minimum is one positive and one negative ion. That's why explain the importance of the chemical analysis table. Right? So you have the cation. So you can see when you're adding only sodium hydroxide or ammonia, you are testing for the cation. That means the positive ions. Right? You can see a lot of PPT here. All these PPT are actually the metal hydroxide. Right? Just let me briefly share with you what happens. Right? I got Xi plus sodium hydroxide. Right? If I see a PPT, all I know is that, okay, based on the understanding of balance equation, whatever on left hand side must be the right hand side. So since I know that there's sodium, there's hydroxide, this PPT is either sodium something or something hydroxide. Now, PPT means it's insoluble. Okay, I mean, there's something that we have to be aware of. Okay, for the pure chem students, you know that precipitate means insoluble. Now, and we also know that all the spa are soluble ones, so that means DPPT won't be sodium something. So it has got to be something hydroxide. And normally the cations are metals. You can see all the cations are mainly metals except ammonium, right? Because metals like to lose electron. That's why we say the PPT is the metal hydroxide. What kind of metal? Depends. If it's a blue, then it's copper 2 hydroxide. Right. If it's green, then it's iron 2 hydroxide, iron 3 hydroxide for reddish brown. If it's white, then it depends whether it is soluble or insoluble in excess. And similarly, aqueous ammonia is also known as ammonium hydroxide because when ammonia dissolves in water, they form ammonium hydroxide. That's why similarly, all the spar are soluble. So that's why even though I change is ammonium something, the same cycle will repeat itself. So all the PPT after addition of sodium hydroxide aqueous ammonia is actually the metal hydroxide. And this ammonium salt is actually based on understanding of a base and ammonium salt reaction. So now we are working backwards, you see. For example, now we add NaOH, we add a X, and we get ammonia gas. Then we work backwards. X must be ammonium. Based on the understanding that a base will only react with ammonium salt. That's how we identify it. That's what I mean by working backwards. Just like going to a crime scene, we collect evidence, but we don't just stop there. We need to use the evidence to help us to identify who are the possible suspects. Okay, for anions, all right, you have a few. Anions is a bit special because different of the ions use slightly different thing. Right? See, acid. Acid normally partner with carbonate. Right? It's the same as how we work on the base plus ammonium salt. So normally acid, carbonate, carbon dioxide, all this normally comes in a pair. When you add acid, you're testing for carbonate. When you add carbonate, you are most likely testing for acid. Right? So you can see that even though when we for the sulfate and the chloride test, we add acid, right? Is to remove any presence of the carbonates. Because if there's carbonate present, the silver and the barium, all right, will also react. If there's carbonate, they will react to form PPT also. So then we will not know that whether is it the silver chloride or silver carbonate. Okay, so let's say for example, without acid, right, then it can be silver carbonate as well. Right? I mean, if there's without acid added, without acidified. So that's why if we add acid, carbonate sure won't be there one because carbonate will react. It will not exist as PPT. So the white PPT must be silver chloride. Yeah, so I mentioned if no additional acid, right, it can either be silver carbonate or carbonates, depending on whether we're looking at chloride or sulfate test. Nitrates, okay. Besides adding sodium hydroxide, one more important thing is aluminium. Right, that's the key ingredient. Without aluminium, then it's not a test for nitrate. Right, it's see, I underline what we are adding. Right, just let me show you example how we work it out for one of them. All right, for example, silver, you have an unknown, you add silver nitrate, you get a PPT. So similarly, like what we do in the cation, we know that this PPT is either silver something or something nitrate. Right? Again, PPT is insoluble, and all nitrates are soluble one. So therefore, that's why this PPT must be a silver salt, and it will make our understanding of insoluble salt is that it must be either silver chloride or silver carbonate. There's two possible choices, but if you have added acid, then of course it can't be carbonate. That's why you get silver chloride, the YPPT, and for you can do a similar thing for barium sulfate. Right? Okay, and last but not least, we look at the gas. Okay, these are some of the important. I mean, some of them we already know already. Carbon dioxide, hydrogen. Okay, chlorine has bleaching properties. That's why those who go swimming often, your hair will be bleached. Right? Okay, and as I mentioned, ammonia is the only alkaline gas. That's why it will turn your red litmus paper blue. Then there is ammonia gas. Right? Important thing is then because by now on the understanding of acid base, they need water. Then they can ionize to produce the hydrogen or the hydroxide ions, which will then change the litmus paper color. Right, sulfur dioxide, later we learn redox, you will know that this is actually an oxidizing agent. So actually this is a reducing gas. Right, it's a reducing agent. That's why it will turn the potassium manganate purple to colorless. Right, this is what we'll emphasize again on redox. So that will be on QA. You need to practice, look at how I stop one of the questions to help you better understand it. Right, so I'll strongly suggest that you try to practice with the QA table, solve it successfully first, okay, without worrying about the memory part. It will come later as you do more and more with awareness. All right. Thank you very much. See you in the next chapter.